Sine x divided by cosine x, it looks like quotient of two things, right? So we apply the quotient rule relying on these two, right? And then we take care of it. In the proof, do you know what is not independent? There's something we use in this proof. Remember when we were proving cosine x, we had to, because of that, you know, we finish it at the very end. What do you use? FTTL, the fundamental theorem about trigonometric limits. You use sine h divided by h approaches 1. You use cosine h minus 1 divided by h approaches 0. You use that fact, right? So seems like we proved it, but it's still relying on that part, right? And then we also showed yesterday that sine h x divided by x approaching 1, we use that to prove that cosine h minus x, let me change it to x, that's minus 1 divided by x, what was the result on that one? It's a 0. Still many of you are using the equal symbol, but it's not equal, it's approaching 0, right? Make sure you use the correct notation. So we use that to prove that. So all this thing is supposed to give you a little bit of idea about the chain of reasoning. This result rely on that fact. That result rely on that fact, right? So do you see that all these things relying on the fundamental fact on that one right here? This implies that using these two, we took care of all that, right? So this is sitting at the bottom of the chain of reasoning. Why is the sine x divided by x is approaching 1? Once that's explained, this proof is complete. Proof about the derivative is complete. Make sense? This guy sits at the bottom of the reasoning right now, and then we can prove it. We've seen the proof of some of the facts about the sine. How is the sine x is defined? Where do we go? Anybody remember the very definition? You go back to pre-calculus course somewhere and look up how is a sine is defined. It is defined on xy coordinate system, right? What was that? Circle? Unicircle, exactly. This unicircle. So that's what sine is defined. So we rely a little bit on the coordinate geometry, but not too much. It's not too bad. All right, so here's a proof. Here's the first quadrant. And I switch to t, not x. So t is going to be here, is going to be an angle. So here's the quarter of a circle. And this equation is x squared plus, not there, it's not a good idea to write it, x squared plus y squared equals 1. That's a unicircle, right? And t is going to be an angle. So t is going to be in here an angle. And positive angle there, t. Radian. T is just a number. And I put a t radian angle there. And that's a unicircle. Okay? If it is t radian, how do you write the x coordinate or y coordinate of that point? If I remember, x coordinate is, how is it related with t there? Cosine, that's right. So cosine t is exactly the x coordinate, and sine t is exactly the y coordinate, right? That's what that is. So we did that before to show sine t approaches 0 as t approaches 0. That was first limit about trigonometry. And we used that to show the sine is in general continuous. All right. So here's their clever idea. It's not something you can come up with in 10 seconds, and they play with a lot. So you just have to kind of understand the idea, not thinking too much about how they come up with that idea. So they're going to pull out sine t divided by, that's their goal. Sine t divided by t has to be pulled out, and eventually they use this squeeze theorem. So let's put that in here. They created this triangle because some of the sides of this triangle involves sine t, right? Which way is that? Is that the height or width? Height, that's the sine t, right? And then the clever thing is that they extended this line, the terminal side, and then put the vertical line up there. Okay? And there's a way to argue that area of this little triangle I'm going to put OAB down there versus OA prime and B prime. Okay? So there's this triangle OAB, and there's a circular arc is in between, and there's a larger triangle OA prime B prime, right? And from that picture, you agree that there's an increasing order. Its area is an increasing order, right? Because you're looking at the picture in that way. But there's a nice way to argue rigorously that using the property of the circle, that it is actually true. A little bit more rigorous than just, looking at it here. But let's accept that. The idea of this area of OAB, triangle OAB, right? The area of that is less than, so let's say the circular arc, sector. Arc is the length, right? The sector is the better word. It's a sector OAB. You see what I mean by that? Circular sector is OA, and then this is including the circular sector in B. That's definitely bigger than this triangle OAB, the area of the triangle. Does that make sense? What is the bigger triangle then? Triangle OA prime B prime. So if you write that down and compute these areas in terms of sine and cosine, and squeeze theorem falls out, and we have a proof. Okay? But all that we assume t is in between 0 and pi over 2. T is somewhere in the first quadrant, and you agree. If it's elsewhere, it's kind of confusing. But how do we take care of the t being negative case? Anybody remember how we did that? We passed the property of odd function and rewrite a t in term, something like that. So we first take care of a positive t approaching from the positive side, and take care of its negative later. Make sense? So let's analyze the area of OAB. OAB here. Half times the base times height. So that's the base there for that triangle. Does that make sense? So what is the base? It's a cosine t, right? It's a cosine t. That's exactly the x-coordinate of that point right there, right? So that's a cosine t. What about the height? That was a sine t exactly. So that part right there is sine t. They're all positive number. Perfect. Here's times a sine t. That's what that is, right? We discussed in this course about the arc length of this one here. That was r theta. Here the angle was t. So the arc length here is rt. But anybody remember the area of the circular sector? That has a 1/2 in there too. Remember that formula? Was r squared theta. That's right. Then theta here is just t. Alright? There's where t kicks in. Everything else, t reside inside the trigonometry. But t is raw here, right? Why is that? It's a connection with the angle. And that's the kind of interesting part. So let's try OA prime and B prime. What's the area of the OA prime, B prime? Let's go for a different angle. What about, this is the leg right there, right? I mean the base of that big triangle. You see that? So what is the base of that big triangle? The whole thing, O to B prime. Cosine prime? Cosine B prime? 1. That's the radius of the whole circle. So 1 is a better answer. All right. Where's the height? A prime, B prime. This is a tricky. Does anybody see that what that's going to be? Let's say we don't know. So let's say I'm going to put H there. So we're going to write it down. Half times base is 1, right? Times that height, H. But you believe that H can be written in terms of trigonometry, in terms of T, right? So let's do a better job. So what is this T? What is this T here? Not T, H. So your job is relating this one to the T. So let me look at this triangle. There's this T radian, and there's this H, and there's this 1. How are you going to relate the T to H? Law of sines. But sine involves hypotenuse and adjacent, opposite, right? That's what sine involves. How about yeah. Right. Let's see if I have. Right. Our goal is in writing the h in terms of t. Of course, we can calculate using the Pythagorean theorem. That we can do that, but that's a lot simpler description. So what is the three information? T is the angle, and this is the opposite, and that's adjacent, right? What comes to your mind? Tangent, right? So let's write down the tangent t. What's tangent t? H divided by 1, right? Adjacent. So H is tangent t. That's the conclusion. It's a lot simpler, right? So if angle t is given, that height right there, a prime, b prime, is simply tangent t. Anybody remember the geometric meaning of a tangent t? Cosine t's geometric meaning of cosine t is x coordinate of the unit circle, correct? Geometric meaning of a sine t is y coordinate of the unit circle. Anybody remember the geometric meaning of a tangent t? Y over x. There's a better name for that. Slope of the line, right? Slope of that line. Because this divided by that looks exactly like rise over run. That's a slope. So that is measuring the slope. If the run part's 1, of course the height there is going to be exactly the slope. All right? So we figured it out. Let's write this one down. You can see that at 1/2 and 1/2, 1/2 cancels everywhere. So we have this inequality, cosine t times the sine t divided by t, that 1 squared. And what is the tangent h now? Tangent t. So since we have cosine and sine, I can write it like this. Tangent t adds a quotient of these two trigonometric functions. Correct? Okay. So this is an inequality they pulled out. And what is that we want to know about? Sine t divided by t, right? But what's available here is t divided by sine t. We can conclude about t divided by sine t here. So what should I do to pull out t divided by sine t? Because sine t here and sine t there, it's common, I can divide everything by sine t. And it's a positive because t is a positive angle here, and up to pi over 2. So when you divide positive quantity everywhere in inequality, the direction of inequality is unchanged, correct? So you cancel that, divide everything. So cosine t survives, and t, there's no sine t, so sine t goes underneath in here, and 1 over cosine t. So that inequality is pulled out, and they realize the behavior of its cosine t as t approaches 0 is pretty neat. What happened to the cosine t as t approaches 0 from where? From the right. With this picture is relying on positive side, right? T being positive angle. So that approaches 1. Exactly. How about 1 over cosine t? Where does that approach? 1. So that approaches 0. So what theorem comes to your mind? There is this one thing trapped in between. This upper bound and lower bound is going to the same places. And what choice does that one have? Had no choice. It has to be squeezed down to 1, right? Squeeze theorem. So by squeeze theorem, t over sine t approaches what number? 1 as t approaches 0 from the right. Well, by limit law, if it approaches 1, its reciprocal also approaches 1, right? And so you can conclude that sine t divided by t, which is reciprocal of that, is approaching reciprocal of 1, which is still 1, and as t approaches 0. So that's a proof of a one-side limit. So let's consider, let's compute. What do we compute? Limit t approaches where? So from the left, right? Just go about from the right. So it's a sine t divided by t. Let's compute that. Let v, what's v is going to be? Everybody remember this trick? Negative t. So that when t is remain a negative number and v become positive, but still approaching 0. So v approaches obviously 0 from where? From the right. That's right. T is negative, v is a positive. Now you write the sine t divided by t in terms of v. Then you can use the limit result about 0 approaching from the right. So what's t here? Negative v. So that's going to be sine of negative v, and this one being negative v. So here, right? Correct? And you can't just pull out, if there is a 2 times b in there, you can't just pull out 2 outside. But if it is just a negative one, you can pull that one out, right? It's a very special property. What is that called? That function is like a parity, right? Called odd function. If the negative value becomes the negative value of the input becomes negative value of output, it's an odd function. The cosine is an even function. If you have negative cosine v, it's the same as cosine v. Negative disappears, but negative pulls out. Once I begin to do that, and student, hey, I have a sine of 3b, I can pull that one out, but that again is not true, right? Only negative 1 can be pulled out. It's negative v. Is that right? So that whole thing is a positive sine v divided by v. V is approaching from the right to 0.1, and that's what we have just proved, right? So that approaches what number? 1. As t approaches what number? 0 from the left. But we interpret it as kind of manipulated so that we can use the earlier result. So both of them approach that. That concludes the proof. So thus, limit t approaches 0 any direction, sine t divided by t is flat 1. And that was used, and let me go back, and to prove the derivative of sine being cosine and derivative of cosine being negative sine, and everything else about trigonometric result, limits or derivative is relying on this result. Even the second part of the fundamental theorem is using this result here, sine x divided by x approaching 1. So that's just the bottom of the chain of reasoning, and we have proved that. So that completes the proof of all the results that we are going to use many, many times. Okay.